All right, number 6. This looks interesting. I've got multiple powers of sine and cosine. I really can't do a u sub quite yet because if I make u sine, then du becomes cosine, and I have 5 cosines. Same thing if I make u cosine, du is negative sine of x, but I have 3 more left. I have to do something else. All right, so I'm going to split this up. It's not so much splitting it up, I guess, as it's a rewrite. I take the power that's odd, in this case the cosine. I pull one cosine out and the other 4 of them stay together. This will give me the opportunity to do a rewrite now. Again, I'm going to take this cosine to the 4th. Remember that cosine to the 4th is actually cosine squared times cosine squared. All right, let me write that. I'm going to recopy. Sine of x to the 4th power. Check. Cosine of x to the 4th is cosine squared times cosine squared. Here's a cosine squared. Here's a cosine squared. Oop, I forgot to write cosine squared. Hang on a second. Cosine squared. See what I did there? A golden sheet. Cosine squared again. Check. And finally, cos x dx. I know this seems obnoxious, but it's the only way that we have to get this. All right, I'm going to FOIL this blue stuff out. When I do, that is going to become a trinomial. It'll be 1 minus 2 sine squared x. And then negative times negative will be plus sine to the 4th of x. Everything else just drops down. Now in green, I'm going to come through and I'm going to distribute the sine to the 4th power into the trinomial, which will give you this. Now we're ready for a u sub. Oh man. U will be sine of x, which makes du cosine of x dx, which we just happen to have one right here. So that's going to be a du. And then the rest of it, we'll just convert to u's. U to the 4th minus 2u to the 6th plus u to the 8th. All right, I have not actually done the integration yet. That's going to happen right now. I think I can still fit it on the page. Going up by a power, dividing by the new power. Again, normally you can't do that with trig, but there's no trig left. It's all red, it's all u's. So yeah, up by a power. So 1/5 u to the 5th. Minus 2/7 u to the 7th. Plus 1/9 u to the 9th. Plus c. All right, the stuff in black is going to be the answer, except remember all u's become sine of x's. So I'll just put my answer somewhere else on the page. I'll just clear out a little space for it. I'll just put it right up there in that cloud. Nice. That's number 6. So again, if you see any problems like that where you have sines and cosines together, you know that u subs are involved. But if you see the larger powers, and especially if one of them's odd, just break off a little piece of it. Break off just a cosine of x, leave the other 4 behind. Since the other 4 are even, you can change them using the golden sheet. All right. Number 7. At first I try to u sub this, I try to do other things, I try to change it to 1 minus cosine squared, nothing works. And then I remember that I've seen this several times before. Again, this is a review section. I'm like, oh, it's one of those, it's a half-angle derivation. I can just write the final answer, which is 1/2 x, always, always, always. Sine is a minus. Normally 1/4. This time it's 1 over 4 times 16. That'll be 1 over 64. This is always sine, regardless of whether that's sine or cosine squared. But it's not 16x, it's double. It's 32x. Plus c. And that's the answer. And it's the answer because I've memorized the form. That happens a lot. You saw it happening a lot when we did volumes of revolution because we were revolving sine and cosine around the x-axis, and it was radius squared, and we had to bust out this formula a couple times. All right, so that's it. Tangent squared of 6x. Man, this is going to be rough. I do want to do a u sub first, a simple little u sub. I want to make u 6x. So du is 6dx. I can put a 6 here, 1/6 up front. At least I can make this look a little nicer. This is going to come out to be 1/6 tangent squared of u du. The thing about this is you don't want to turn tangent squared into sine squared over cosine squared. I mean, it is, but if they're both squared, you can't use them to u sub each other with. So that's not going to work. What will work is another Pythagorean identity. You may remember from the golden sheet of trig that tangent squared plus 1 is secant squared. So going backwards from that, secant squared minus 1 takes you back to tangent squared. And since secant squared minus 1 is tangent squared, I'm going to change this into secant squared minus 1 instead. All right, now we can integrate. The integral of secant squared is the derivative of tangent. So the integral of secant squared is just going to be tangent of u. So we're going to have 1/6 way out front. The integral of secant squared of u, as I mentioned, is tangent of u. Let's put the u back in. That was a 6x. And then we integrate this part. The integral of -1 or -1 is minus, don't say x, it's minus u. You know, I know it's a u is because this differential's sitting there. It tells you what letter it is. Minus u, but remember u is 6x. Okay, plus c. I'm going to go ahead and bring the 1/6 in, mainly because I don't like the brackets. And that's it. 1/6 tan 6x minus x plus c. When I saw this and I knew I couldn't do it in any normal sort of way, I thought back to number 3 where we split the numerator into a couple different integrals, but you can't split the denominator. That's not legal. So that's not going to work. Instead, I'm just going to have to rewrite this. And it's a form of completing the square, really, is what it is. I go x squared minus 6x, and then in my head, I'm thinking, if I take half of that -6, that's -3. If I square that, that's a plus 9. It's too bad it's not plus 9 instead of plus 13. Well, you know what? What the heck? Let's just go plus 4. That way I still have my plus 13. It's still there. But now I can take these first 3 and I can say that is x minus 3 quantity squared. So I can rewrite this problem to suit my needs. So that's what I did. You can see I took the denominator, I used commutative property and just wrote it in a different order. And the reason I wrote it in a different order is I can already see arctangent or inverse tangent coming our way. We need this 4 to become a 1. We have no choice. We have to divide by 4, which means we have to divide everything by 4. All right, so once I redo that, it'll look like this. All right, we'll do a u sub, one of those triple u subs. All right, so this is now u squared. The 3/4 can get kicked out. I'll put a 1/2 inside. I'll put a 2/1 on the outside. The 1/2 dx becomes a du. Let's rewrite this. So we have a 2/1 out front, joined by a 3/4 that just got kicked out. Integral. The numerator has nothing left, so a 1 is holding down the fort. 1 plus u squared, and the 1/2 dx is du. Perfect. I just turned this into an arctan. Some gentle canceling out front will make 3 halves. So we have 3 halves, arctan, or inverse tan, of u. And of course, u is the x minus 3 over 2 plus c. So we went from what looked like an impossible problem, we kind of broke it apart using a little trickery. We rewrote the 13 as a 9 plus 4, which is totally fine. But I used a little bit of completing the square to make it happen. So again, your Algebra 1's always alive and well. It's always ticking. All right, one more problem. Here we go. All right, well, we're going out strong. My goodness. Okay. Well, does the denominator factor? Let's try this out. It looks to be 2x minus 5 quantity squared. Yeah, that's awesome. Now, I don't necessarily want to do a partial fraction with repeated factors. There must be another way to do it, and there is. I'm going to break this apart again, and here's what I'm going to think about as I do it. I know eventually I'd like to do a u sub, and in this problem I should be able to because I've got 4x squared in the denominator. I've got a regular x up top. Now, let's try this. I'm going to make the u the denominator, the pre-factored denominator, if you will. Du is going to become 8x minus 20 dx. Oh, but that's an 8x minus 23. Too bad it's not a 20. Hang on, everybody look away for a second. There, that's better. Now see, that would be really cool. Then the problem would be easy. The problem is it wasn't a 20, it was a 23. But couldn't you just do this? It doesn't hurt. That's still 8x minus 23, but I cleverly rewrote it in a way where now I can break this into two separate integrals. Whoa. Okay, hold on. Okay, what have I done? I broke the numerator into two parts. I took the 8x minus 20. Here it is. I took the minus 3 and put it in the other integral. There it is. I factored the minus out. And then, obviously, I had a common denominator. I elected to write it in the factored form over here, but then I decided to leave it original over here. It doesn't matter which way I write it. It's the same thing both times, but it's going to make the problem a little easier to integrate. Let's look at the green integral. It's all ready to roll. It is already 1 over u du. Because remember, the du was the 8x minus 20 dx, and I have that right here. And the rest is just u. It's in the denominator. So that's going to turn into natural log of u. All right, over to the blue integral. The blue integral needs its own u sub. So I'm going to call u the 2x minus 5. Du will be 2 dx. So here's a 2 on the dx, a 1/2 out front. The 3 will get popped out front and join it. So this will be minus 3/2. We have an integral. The 2 dx is this du. But now we have u squared on the bottom, which is u to the negative second, which is not a natural log. It's up by a power divided by the new power, so we're going to have minus 3/2. This will be u to the negative first times a negative 1, and then a plus c at the end. All right, natural log of u, but this u refers to that. So, okay. Here on the blue part, negative times negative will be plus. I think I'm going to write it like this. 3/2, and then u to the negative first is in the denominator. This time the u is up here. It's the 2x minus 5 that we're referring to. And then plus c. All right, there are a few other ways you can write it. Some people will ask, is it okay on the blue part if I distribute the 2 and make it, 4x minus 10. I'm like, yeah, that's totally fine. Other people are like, can I leave it as 2x minus 5, the negative first power up top? I'm like, yeah, as long as it means the same thing, you're okay. Other people are going to say, what about the green part? Do you really need absolute value there? I'm like, well, do you know that it's going to be positive all the time? And they're like, yeah. Because remember, the trinomial inside is really the same thing as 2x minus 5 squared. So if it's squared, you know it can't go negative. I'm like, oh, very nice. That's impressive. But then somebody else tries to one-up them, and they're like, why don't you just write 2x minus 5 squared? At this point, people are just starting to show off. And then somebody else says, well, then you can bring the 2 down. Now, everything is correct here. I mean, everybody's making good points. Although I would say if you bring the 2 down, now the 2x minus 5 is not guaranteed to stay positive anymore, so maybe you should absolute value it again. And we can get into a whole realm of conversations that most people don't want to have. And it's really impressive, though. So, again, if you're not sure if your answer is the same as the back of the book or some other person's answer, just let me know. We can talk about it. All right, what a wonderful review of all the integration we've done, rolled into one section. I've got a worksheet that I made that has a lot of these techniques on it just for you guys to practice for homework. And that's it. All right.